Now for some common questions. We often get asked, why can't I code how I want to? Well, the answer is simply that synthesis tools and the Xilinx implementation tools cannot do as much of the work as customers would ideally like. In the end, there will always be design work necessary to compensate for synthesis and implementation tools, regardless of what vendors. This is especially important if you're going to try and get the most out of any FPGA product family. And you can also consider this a factor that new products always have new technologies associated, and it simply takes time for people to catch up with the new technology. Another common question is, shouldn't the tools be able to make my code optimal? Well, the bottom line is synthesis and implementation tools have limitations, and they always will. This is exactly the reason we provided this content, so you can improve your design, so you can get the most out of your Virtex-5 design. Some more common questions. The Virtex-5 FPGA should always be a speed grade faster than Virtex-4, right? Well, no, this is not always true, especially if the design was heavily pipelined and hasn't had any design work to upgrade it to the new 6-input lookup table. So the answer there really is a factor of you won't get the high speed performance until you do a bit of design work to take advantage of the Virtex-5 features. Another question is, this design easily fit in Virtex-4 and now it can't fit in Virtex-5. What's wrong? Well, remember to check your control sets. I'm willing to bet you have too many. Check your use of resets and clock enables as well. You should also remember that each device family has a different set of dedicated hardware. Ask yourself this, did you use as much of the dedicated hardware as you could? Well, don't forget to make sure that your cores also share the same control signals as you built with your HDL. Another question, why can't the software just optimize my inverters across a partition? Well, remember the purpose of partitions, and again, now we're talking about incremental design, where a designer may want to isolate logic and not allow it to change between implementations because they tested, they verified the results, the timing, the simulation, they like the results, and they want to keep it now. Well, this whole idea about partitions is for the designer to control the hierarchy and preserve logic. So if any tool just went around and changed logic, added the inverter and recoded it, customers would scream because their logic would change, and of course then the simulation, the verification results would have to be gone through again. So it would be counterproductive to the whole idea of true incremental design and maintaining partitions. Well, I tried to provide a detailed summary of the most important coding tips we provided in this module. Well, in this module, we talked about some of the synthesis recommendations, and we told you to turn on logic replication and retiming, turn off resource sharing, turn on logic optimization, turn off finite state machine optimization, do not over-constrain during synthesis, and do not use slice or LUT compression switches. And these are, of course, for one main reason. We're trying to reduce the total number of registers our design uses, okay, so that we give the tools flexibility to move logic around the FPGA to gain timing closure. We also told you to be careful with coding unnecessary clock enables. Just the same idea with the number of resets, we want to minimize the number of low fan-out clock enables we have in our application. This will reduce the number of control sets we have in our application, again giving the tools more flexibility to meet timing. IOB registers can make it more difficult to meet internal timing, and this is of course because that register is tied to a pin. So that limits the ability of the tools to move logic near that register, forcing sometimes to have longer net delays. Okay, so our solution to that was we want to tell you to override the default behavior of the tools, both your synthesis and the implementation tools, to use those IOB registers automatically, but instead only use them for I/O timing. And the best solution there was hopefully your synthesis tool using timing constraints to migrate registers into the IOBs. And if not, we described a process for you to manually override the tools and to physically assign specific registers into the IOBs. And we told you, finally, follow our guidelines to ensure that your design does not interfere with design optimization and incremental design practices. And we talked about some of the caveats that people will sometimes experience when doing a true incremental design flow. We discussed the issues of revolving hierarchy. Well, there are lots of places to learn more about FPGAs, and they all start at support.xilinx.com. I want to point out that I referenced several white papers, both in the last REL as well as this one, and you should consider reviewing them. They all provide more information on optimizing your design and HDL coding for FPGAs. The third white paper, Get Your Priorities Right, pertains to Spartan 3 and older Virtex devices, which are 4-input LUT-based devices. The first two are specific to Virtex-5. I also spoke about a user guide for DSP slice resources. That was UG or User Guide 193, the Virtex-5 Extreme DSP Design Considerations document. It provides insight into the slice construction and offers numerous suggestions for its use. To make sure you're getting the most out of your Virtex-5 device, I recommend you check it out. I also mentioned the constraints guide that is located on our website as well as accessible from the help menu of the ISE tools. This guide covers all the Xilinx supported constraints, including XST's support of timing constraints with what is called the XCF flow. I mentioned this guide when discussing how to assign specific registers to IOBs. We call that a mapping constraint. Have a look at the constraints documentation, but I'll warn you, there's a lot of detail there that you're not quite ready for. So you might get the most out of it after you've attended the Fundamentals or Essentials of FPGA Design course and the Designing for Performance courses.